move to the last presentation of this afternoon session. Taygun, Uzelli and colleagues, possible precursory anomalies, again anomalies and precursory anomalies on groundwater level and geothermal resources associated with before and after the Samos earthquake. Dr. Uzelli?
Thank you, Professor Caputo.
You share the screen, full screen, please.
Can you see?
Yes, thanks. Fine. You have the floor.
Okay. Good afternoon, ladies and gentlemen. My name is Taygun Uzelli. First of all, I would like to thank the organizing committee of this organization and this important workshop. And also thanks for inviting me. That's a good opportunity to share our findings and research with many researchers around the agency. Today, I will talk about the possible precursory anomalies in groundwater level and geothermal resources associated with before and after the October 13, 2020 Samos earthquake. Here is our team. I feel lucky because we have a team of very special researchers who supported and contributed me during this study. I would like to thank Esra Bilgiç, Bahadır Öztürk, Professor Alper Baba, Professor Hasan Sözbilir, and Professor Orhan Tatar. As seen from the team, this study conducted in cooperation with different universities such as İzmir Institute of Technology, 9 Eylül University, and Sivas Cumhuriyet University. Within the scope of this presentation, I will first talk about the aim of the study and the location of the study area. Next, I will speak about the groundwater studies in Bayraklı region, then the geothermal fields, and finally, I will end up my presentation with results and discussion part. The purpose of this study was to examine the effect of the Samos earthquake swarm in Izmir. Observations made within the scope of this study are mostly based on relationships between earthquakes and water level changes, and also anomalies in geothermal activity, physical and chemical properties of geothermal fluids. In this context, our studies have started in Bayraklı district, Gülbahçe and Tuzla geothermal fields. We started working immediately after the earthquake. We went to Sığacık region where the tsunami event took place, and the tsunami was an earthquake effect occurs in seas and surface environment. So at this stage, the following question comes to our minds: how were groundwaters and geothermal systems affected by this earthquake? To answer this question, we choose three study areas. The first one is Bayraklı district. The second one is the Gülbahçe geothermal field. The third one is the Tuzla geothermal field. Let's have a look at the Bayraklı groundwater studies. After the Samos earthquake in Bayraklı, buildings on quaternary alluvium saturated with groundwater were seriously affected, and 17 buildings were collapsed, and severe damage and casualties occurred. This region also affected by the destructive earthquakes in historical records. In this figure, you can see historical coastline changes and all the riverbeds. The white colored region you see now correspond to the places thought to be under the sea during the time of the ancient city of Smyrna, and even in the 1900s. Actually, we were so lucky and prepared as the İzmir Institute of Technology. We were actively monitoring the groundwater in the Bayraklı district. In Bayraklı, 10 groundwater observation wells were installed in the alluvial plain to assess responses in groundwater level. The groundwater level in this area is very close to the surface. All wells were drilled to locations where building and groundwater interaction is intense. Some buildings that collapsed after the earthquake are very close to the well locations. This situation shows how accurate the well selection was made. You can see the conjectural old coastline in Bayraklı, old riverbeds, and also collapsed buildings after the Samos earthquake, and our sampling wells. These are images from our study. You can see the drilling phase, diver placement process, and diver data collection process. We use 3 types of diver data loggers in 5 of the observation wells, and these divers can take measurements with desired time intervals. Divers were set to read the data in every 1 hour, and TD diver was located in 4 of the observation wells, and Barrow diver and CTD diver located in 1 well. These are our monitoring parameters: water level, temperature, and electrical conductivity. These parameters also periodically correlated with divers' measurements and verified by classical field measurement methods. Within the scope of this study, earthquake data of AFAT were used for correlation. There is an important information about our observation process. During this study, there was a period without precipitation in Izmir. There is no other working wells near our observation wells, so for this reason, water level change is not affected from these factors. In this figure, a time-dependent graph of temperature measurements taken from 5 different wells at 1 hour intervals are given. You can see the Samos earthquake time. During the period of 1 and 2 days before the Samos earthquake, changes in the temperature of the wells were detected. While these anomalies were in the form of temperature increase in wells such as S1 and S3, temperature decreases were observed in other 3 wells. The situation indicates that there was a temperature-based change in groundwater before the earthquake. During the Samos earthquake, the temperature values in all wells decreased significantly for a short time and then rose suddenly to a level close to or higher than the previous level. It is thought that the reason is entry of the waters with different temperatures from the outside into the stagnant well with the earthquake waves. Similarly, the temperature change in wells before the 20 November earthquakes can be seen in figure. Our divers recorded some pre-seismic indicators, and they show that the water level rises 2 days before the event, and this is approximately 10 to 20 centimeters. And this situation took about 7 to 10 days after the main shock for the water levels to recover their former static levels. You can see again the water level change before and the time of the Samos earthquake. We also observe electrical conductivity in well number S9. The electrical conductivity observations show that the bottle-rock interaction has increased with the tension before the earthquake, and then waters with high electrical conductivity, it's possibly the seawater intrusion in the Bayraklı, mixed into the well. After the earthquake, the water left the well with the shaking, and the water level started to return its former state. Our observations indicated that the dates of the earthquake swarm and the time interval when water levels remained higher are almost the same, and both lasted for 7 to 10 days. This is an important indication that seismic activity can keep water levels under control for a certain period. In previous studies, we know that the groundwater in Bayraklı are of the calcium bicarbonate type. So, as can be seen in Piper on the left and Schöller in the right diagrams, S9 and S1 wells have higher sodium chloride concentrations than other wells, and this situation shows that these wells affected by seawater intrusion after the Samos earthquake. Temperature changes in S1 and S3 also can be associated with seawater intrusion and consistent with this situation. Let's have a look at our geothermal fields. Tuzla and Gülbahçe geothermal fields are located on the north of the earthquake epicenter. As a result of observations made in the fields after the earthquake, there are some anomalies detected in geothermal fields, such as the responses in chemical and physical properties of geothermal fields. You can see our monitoring parameters. We have some field observations, such as new source formations, gas liquids, and liquefaction areas. Gülbahçe geothermal field, structure contours by right lateral strike slip and normal faults of the Gülbahçe fault zone. geothermal sources formed in the regions where faults intersect with each other. Secondary permeability in these zones controls the fluid circulation. With the seawater intrusion, there are sodium chloride type hot springs with a temperature of nearly 35 degrees Celsius. After the Samos earthquake, new spring formations whose temperature reached to 40 degrees Celsius can be observed. And also there are some gas leakages in the sea after the earthquakes. You can see some examples of our observations, and you can see the sand volcanoes on liquefaction site in the Gülbahçe Bay. In the Tuzla geothermal field, geothermal fluid comes from the basement units through the fault segments. It is possible to see hot water springs on the right lateral strike slip segments of the Tuzla fault zone, where the fault step over and/or bend. Fluid channels on the fault plane gained activity after the earthquake. A new hot water outflow started on one of the fault segments. You can see the images from the fault planes, while you see the first activity 2 days after the earthquake on the left top side, and you can see the new sources formed after 5 days on the right image, and this is the zoomed in view of the fault plane. In addition, there are some mud and fumarole outlets were detected in the field. The temperatures of geothermal fluid reached the surface from the fault plane ranged from 78 to 99 degrees Celsius, and this activity still continues. Temperature and electrical conductivity increases detected in the field studies, and these values as the same as the deep geothermal wells values. We have sampled this region. You can see the Piper and Schorler diagrams of the our samples. The sample A and sample B are taken from the geothermal fluid samples on the Tuzla fault segment. These resources as the same as the natural hot springs in the how can I say? There are lots of hot springs in this region, such as Doğan Bey, Karakoç, and other springs. But and this geothermal fluid also have a sodium chloride character. However, they have higher iron concentrations like fluids in the geothermal wells of the region, because they quickly came from the deeper reservoirs along the fault plains after the Samos earthquake. As a result of studies carried out, some obvious results and observations have been revealed. 10 wells with 10 meters depth were drilled in Bayraklı region before the earthquake. Temperature, water level, and electrical conductivity automatically measured at regular 1-hour intervals by the divers in all 5 of wells. Especially the water level rise steps observed in shallow wells in Bayraklı, and this is possibly due to the compaction of the geological units during the earthquake. It's a significant finding that changes in temperature, water level, and electrical conductivity in these observation wells were detected before and after the Samos earthquake. Geothermal anomalies in İzmir city have been studied in detail, and significant anomalies were determined during and after the earthquake in 2 important geothermal fields, Tuzla and Gülbahçe geothermal fields and related fault zones affected by the Samos earthquake. New hot springs formed in the Gülbahçe field. We observed some liquefaction and gas leakage areas on the seafloor of Gülbahçe Bay. Similarly, in the Tuzla geothermal field, we have some new hot spring outlets along the Tuzla fault plains. In addition, as we seen from the yesterday's earthquakes, this activity in the region still continues. If more observation stations are established in the different geological units with networks, higher quality and accurate groundwater level, chemical and physical response signals will be obtained. So these monitoring studies can be very useful in the long term in predicting future and earthquakes. Thank you very much for your attention.
Okay, thanks for the presentation. Interesting observations. Have a look. Congratulations. Questions on your interest in innovative work. What kind of studies are you planning to do on this subject in geothermal fields in the future? That's the question from the audience.
Yes, thank you for the question. As mentioned in the presentation, this study contains preliminary findings of our newly started monitoring process. We are currently monitoring these regions. As a priority, we are trying to increase the number of the wells, the divers, and also the samples in the study areas. In addition, if we may convert this monitoring process to a monitoring via an online system, instead of reading this data from the field weekly, we will have able to analyze it more faster. So with future projects, I hope we can make our studies more comprehensive with more innovative and new approaches such as and other methods and radon measurements, isotope measurements, etc. Thank you.
Okay. We have a few minutes. If there are some questions also for the previous presentations. Some curiosities and questions. No. Okay, Oran, I would say.
Okay, so we can have a longer coffee break.
Just a little bit longer, yes.
Longer coffee break, yeah.
We need some relax. And we will be back in time at 15:55 Greek and Turkish time, which is 14:55 Italian time, I remind you. Be in time, please. Thank you.